Hi guys, I Aziz welcome you to CoedMaster. So the topic for today's session is how to fetch a file in chunks. So guys, there are times when we need to implement a feature in our web application or website where we need to give an option to our users to view a video file or give it a feature to download a file. So there are multiple approaches to solve this problem. So the simple and straightforward approach is to use a video element and give a video URL to the source of video element. And for downloading a file, you can simply use an anchor tag and give it a download attribute. So using these two approaches, user can download a file and view the video. But this is not the only way to solve this problem. Obviously, this is a more traditional way to solve this problem, and in this solution we are delegating everything to the browser to download the file and view it to user, right? But in this video we are going to see another approach to solve this problem. So we will see how to download or fetch a file all at once and display it to user. And second thing, how to download a file in chunks and display it to user. So these are two approaches, and both of these approaches is a programmatic way to solve this problem. So in this video, in approach 1, we will see first of all how to fetch entire file at once, and then we will see the code walkthrough, how to implement it, and then we will see a demo around it. And then we will see the another approach where we are going to download a file in chunks in parallel, and then I will show you a code walkthrough, and then I will give you a demo of it. And then in the last, I will give you some advantages of downloading a file in a chunk over downloading a file all at once. So without wasting any time, let's get started. Alright guys, so first we will see how to fetch a file all at once. So on the left hand side we have a browser, and on the right hand side we have a file server. So in order to download a file, browser needs to send a request to file server. So here browser is sending a GET request to a file server. The request reaches to file server, then file server checks if file exists or not. If file exists, then our file server will going to send a response back to browser that okay browser, I found the file and you can download it from there. And the server is going to send the response 200 okay. Once browser get the response back from file server, it's gonna start downloading the file like this, okay? And once the file is downloaded in the browser is going to display the file to the user. As simple as that. So in this case, I am taking the example of video. So browser downloads the video and then display it to user, and user can access the video, right? So this is how we can download the entire file at once and view it to user, show it to user, okay? So now let me show you the code walkthrough that how programmatically we can achieve this, and we will see the demo around it, okay? So let me switch to VS Code. So here I have a simple boilerplate code for this demo. Here we have some style, we have one container. In this container we have two buttons, fetch all and fetch in chunks. Here I have a progress bar and a video element. So progress bar we are gonna use in the next approach, okay? So here I have a video URL. Here I am fetching the reference of button 1, button 2, video element and progress element. And here I am attaching event listener on button 1. So as soon as user clicks on button 1, we are sending a fetch request to video URL, and it's going to be a GET request. Then I am checking if the response is okay or not. If response is not okay, which means there is some error on client or server side, then I am throwing an error. After this, I am getting the response as array buffer. Now, what is array buffer? Array buffer is nothing but it is a storage where we can store the binary data. So when browser fetches the file, we are asking to give the video file in the binary format and in the form of array. Okay, so this array buffer stores all the bytes in the form of array, and then we are supplying this array to a blob, which is a binary large object, to create an object for us. And using this object, we are creating a URL, and this is going to be the in-memory URL or temporary URL. And then we are setting video URL to video element, and then we are playing the video. And after all of this process completes, we are gonna console the time which is taken to fetch the file. So this is a very straightforward example and very straightforward code. Cool. Now let's move on and see the demo working live in the browser. So let's open the developer console. Let's clear it up, and now let's go to network tab, clear everything, and let's click fetch all button. So you can see that when fetch all button clicks, the browser sends a get request to this video URL, and in return it gets the response back, and the response status is you can see the response status is 200 OK, and immediately browser starts downloading the file. Okay, so for your information, the video file is 158 MB in size. So it's gonna download the file. It's 140, 45, 48, 50, and soon we will see the video. Now see, 158 MB is downloaded, and we can see the video over here. Now we can serve the video like this. So this is a programmatic way to fetch the video URL, fetch the video, and then display it to user. So far so clear. Cool. I hope you got the idea of it. Now let's talk about the another approach where we are gonna fetch a file in chunks. So again, we have a browser over here and we have a file server over here. Now instead of fetching the entire file at once, the browser is gonna fetch one piece of information from the file server. So it's gonna fetch one chunk, and then another chunk, and then another chunk, and so on and so forth, and then it's gonna compile or combine or glue all the chunks, create it one file, and then view it to display it to user. So the question over here is how to implement this feature, how it works actually. So to understand this problem, let me give you a real life analogy, and we will understand this problem with the real life analogy. So for example, if I give you a metal rod, and if I tell you that okay, you have to break this metal rod into smaller pieces, and also when you were performing this task, give me the progress of the work, that how much work you have done. So after analyzing this problem, you come to me and ask me a question, very simple question, that what is the size of this rod? So I said okay, this rod size is 8 feet long. Okay, you ask another question, that what is the size of each piece? So I said okay, you can break this rod into small pieces, and the size of each piece is going to be 2 feet. You said okay, let me start doing my work. So you made a first cut of 2 feet, and you inform me that my 25% work is done. Then you make the another cut, and you inform me that my 50% of work is done. Then you make the another cut, and you inform me that okay, my 75% work is done, and then you inform me that my 100% work is done. So this is the approach you taken to solve this problem. Now let's implement the exact same analogy in the context of fetching file in chunks. So here is our browser, here is our web server. Now you ask me the same question, that if we want to download the file in chunks, and what is the size of file? So I said okay, the file size is approximately 8 MB or exactly 8 MB. Then the next question would be, what is the size of each chunk? So I said okay, we can download the chunk, and the size of each chunk would be 2 MB. So far so cool. So now browser first sends a request to get the file size. Why is it so? Because before downloading a file, we don't know the size of the file. So this time, first step is to get the size of the file. So browser sends a head request. Remember, please note here that browser sends a head request instead of the get request to get the size of the file. So in return, browser gets the 200 OK response and with the content length header, and this header gives a size of the file. So for the sake of this example, I use the MB, but usually the content length header gives us information in bytes. Okay. So this is the first step as per our analogy, that what is the size of rod. In this case, what is the size of a file. So by sending the head request, we got the size of the file. Now moving on. After getting the size of file, we now understood that this is the size of a file. Now we can easily know the size of each chunk and what to fetch from the server. So browser sends one request and asks server, hey server, give me the chunk 1. And in return, browser file server sends the response 206, which is a partial content. Why is it partial content? Because we are not fetching the entire file. We are only fetching the a segment or a piece of file. And the content length is 2 MB. And we got informed that our 25% of work is done. So far, so great. So this is how browser fetch the chunk 1. Then browser again sends the request and it's gonna fetch chunk 2 this time. Similarly, it's gonna send another request to fetch chunk 3. And last, it's gonna fetch chunk 4. And by combining all the 4 chunks of each size 2 MB, we got our 8 MB file in the browser and our work is done 100%. Now we are gonna club all the chunk together and display it to user. Okay, so this is a very straightforward approach, right? But instead of fetching all the files, entire file at once, we are fetching all the chunks and then combining all the chunks and display it to user. Cool. But my friend, the story is not yet over. Why is it so? As we are fetching all the files in chunk, we are fetching a file in chunks, but I don't think this is the optimal way to do this. We can still optimize this solution. So how can we optimize this? So guys, you know that in JavaScript, we can send the parallel request, right? We can send parallel request using promises, or you can spin up a worker thread to send the parallel request, right? So instead of sending all the requests sequentially as we were doing over here, we are going to send 4 parallel requests to file server. So the browser simply tells file server, hey server, give me the chunk 1, chunk 2, chunk 3 and chunk 4. File server receives the request and it's gonna give all the chunks to browser. So browser is going to receive chunk 1, chunk 2, chunk 3, chunk 4 all in parallel, with a response code of 206 partial content. So with this, in one go, we got the entire file, we combine all the chunks and display it to user. So this is the most optimal way to solve this problem. And as you can see, the user can now view the video. So the question over here is, this is a pretty much a very decent and very nice idea, but how to implement this feature? Okay. So let me show you the code walkthrough to solve this problem and then we will see a demo. Okay, so let's jump into the Visual Studio. So first of all, here we have a video URL, a click listener on button 2, a video element and then a progress element, correct? Here I have taken a constant where I have defined the chunk size. So the chunk size is 20 MB. So in first request, we are gonna fetch 20 MB of data. Okay. The second thing I have taken is the maximum parallel request. This is going to be a queue size. So we are using the queue data structure over here. So I will show you how to use it. So in order to get the file size, I have written one function which is a get file size, which takes a video URL, sends a head request to that URL, and then fetch or capture the content length header. So the content length header gives us a size of a file in bytes. It's a very simple implementation. Now I have written one more function where this function is going to fetch a single chunk, and it returns an array buffer which includes that chunk. Now here we are sending a fetch request again, a get request, okay, and this time we are doing something very different here. So here you can see that we are receiving start and end. So this is going to be a pointer to fetch the chunk. So let me give you an example. So let's say we have 0, 1, 2, 3, 4, 5, 6, 7. So 7 bytes of data. So what start and end means, these are the 2 pointers to fetch the chunks. So let's say I want to fetch first 2 bytes. So my start will be here and end will be here. Then I will fetch the another bytes. So my start will be here and the end will here. Then I'm gonna fetch another bytes, and so on and so forth. So this works as a pointer to fetch the individual bytes. And to fetch the individual bytes, the request we are sending to file server also includes the header, and the name of that header is range. So if you don't know about the range header, it usually used to fetch the partial content. Okay, so we're using a range header and give it a value of bytes that I want to fetch the bytes from start to end. So this is how we are going to fetch a specific byte from file server, and then we receive the response. We check if response is okay and the status code is 206. If it is, then we are going to return a response in the form of array buffer. Otherwise we will throw an error. As simple as that. Cool. Now here comes the important function. So this function is responsible for fetching all the chunks. Okay, so you can see the definition of this function. We are receiving URL of the file, the size of the file, the size of chunk, maximum parallel request, which means the queue size, and the progress callback. So what is a progress callback? By using the progress callback, we can update the progress of the file. Okay, over here we have a progress element over here. Cool. So let's understand this function little bit better. So here I have used 3 variables. One variable is to store all the chunks. So let's say we are downloading 4 chunks. So we will store all the four chunks inside of this array, and then we will combine or club all the chunks. And then we have a promise queue. Why promise queue? Because we are going to send a HTTP request, and the HTTP request always gives us a promise. So we are going to store all the promise in this array, and then we are using one variable with the name downloaded bytes. So as soon as we download the chunks one by one, we will append that how many bytes we have downloaded so far. So to maintain that thing, we are using a one variable over here. Then there is another function inside of fetching chunks, which is a process queue. So we are going to process the queue. We wait for this process queue to be completed, and then once the process queue is completed, we are going to sort the chunks by the start. Why? Because it may be possible that your chunk 2 comes way before than chunk 3 or chunk 1, or your chunk 4 you receive chunk 4 way before chunk 3. So you have to arrange all the chunks by their start time, or we can say the pointer. Okay, so we are combining all the chunks, and then we are mapping by extracting the chunk out of all the objects. So I will show you why the significance of this line a bit later. Okay, so I have taken one pointer, start pointer, and then I am checking if the file size, if the start is less than file size, to determine that we still left with some bytes. Okay, and then again we are checking if our promise is full or not. How to check it? We simply checking if promise queue.length is less than maximum parallel request. Okay, if our promise is full, then we will implement something, we will do something else. Okay, I will show you in a bit. And then we are finding the end pointer by comparing the file size and start plus chunk size minus 1. What is the significance of this line? May be possible that your chunk size is 2 MB and your file size is 1 MB. So in that case, what is the minimum? The file size. So the end pointer is going to take the correct value. Okay. If the file size is greater than your chunk, then we are finding the end by summing the start plus chunk size minus 1. Okay. So far so great. Now we are assigning this start to actual start, and the reason is simple, that this promise callback, this one is going to execute later in time when the promise resolves. So by that time your start pointer may change, so you have to preserve this start pointer to push the object in the chunks. And the JavaScript callback is going to be use the closure over here. So it's create a closure over the declared variable, and then it's gonna use that variable. Okay, so here we are using this function fetch chunk, which I showed you just before. After fetching a chunk, so it's gonna pass URL and start and end pointer to this fetch chunk. It's gonna receive a promise. We are registering the enable. Okay, so once the promise is resolved, we are gonna get the array buffer. So we are pushing a special type of object in the chunks array, where we are storing the start and the chunk as an array buffer, and then later we are going to sort these chunks based on the start as I showed here, and then we are extracting the chunk from here so that we have an array of chunk. Then after downloading the bytes, we are adding the bytes length to the downloaded bytes variable. And if we have any progress callback register, then we are informing that okay, this much work has been done. Then after the promise is resolved, we need to obviously remove that promise from the promise queue. So we are filtering the promise, and except this promise we are keeping all the promise in the promise queue. After that we are pushing promise to promise queue, and then we are resetting the start pointer to start plus chunk size. Okay, moving start pointer forward. So this is the case when we have space available in our promise queue. What if our promise queue is full? Okay, so in that case we are going to wait for some promises to be resolved. Okay, and for that we are using promise.race method. So far so great. And then after processing the queue, we are sorting and then mapping. Okay, so this is the main function which fetches all the chunk, and in return it's gonna give us a chunk of all the bytes. Okay, now below here I have registered a click event on the button 2. Okay, so the button 2 is sending a request to get file size. Okay, it's gonna get a file size, then it's gonna call a function fetching chunks by passing video URL, file size, chunk size, maximum parallel request, and the next one is a callback, and this callback is nothing but a progress callback. Correct? And the progress callback is going to get the done and total bytes. So we are computing the progress value by using done and total. And what is done and total? Is simple. Total is the total file size and done is the downloaded bytes. Okay, and then this function is going to return a chunk of all the bytes. So by using chunks of all the bytes, we are converting into blob, which is a binary large object. Then we are giving binary large object to url.createObjectURL, and this is going to return a URL, and then we are attaching that URL to video source attribute, and then we are playing the video. And in the last, we are consoling the time taken to complete this process. Okay, so this is the entire code. Now let's see this code in action. So let's go live. Let's open the terminal, go to network tab, and then click fetch in chunks. So guys, you will see that the first request is the 200. It is head request. The server sends the positive response, and then we have sent the 4 parallel requests. You can see all 4 parallel requests is fetching the files, and all request got the 206 partial content. Okay, so now our 4 queues So by sending 4 requests, our queue is full. So then we are waiting for queue to become empty, and then again after queue becomes empty, we are again sending the 4 requests, 1, 2 and 3 and 4, and all request is fetching 2 MB of data. So in total we have sent 1, 2, 3, 4, 5, 6, 7, 8 requests so far. So after fetching 8, how many requests? 1, 2, 3, 4, 5, 6, 7, 8. So after sending 8 parallel requests, we are able to fetch the entire file. Okay, and if I look at the console, you can see that it took 35 seconds to download the file. Okay, so this is how we can fetch the file in parallel, and you can see the progress bar over here. So while downloading, we can also see the progress of our downloads. Cool. So guys, I hope now you understood that how to fetch file in chunks. You have a very good idea now. Okay, I hope. But this begs the question that why we should go with the approach 2 over approach 1. What are the advantages of fetching the file in chunks? So let me give you few advantages of going with the approach 2 over approach 1. So let's understand the first advantage, which is a visual feedback. So when user downloads the entire file at once, he do not receive any visual feedback. But if we allow user to download file in chunks, they get the good visual feedback using the progress bar, which leads to a better improved user experience. The second advantage is resumability. So when we allow user to download the file at once, we are not giving user an option to resume the file in case of any network discrepancy or any interruption happens in the network side. So when we give option to download file in chunks, we give option to user to resume the file in case of any network interruption. Okay. Now the next reason is robustness. So using this approach, we can build our system more robust to failures. So for example, in case of this example, if any of the chunk fails because of any system error or anything, so we can drag the failed chunks and we can retry that chunk later on. So with this approach, we can build our system more robust to failures. The next advantage is concurrency and parallelism. So when we were downloading entire file at once, we were not taking the advantage of concurrency and parallelism. But when we download file in chunks, we took the advantage of parallelism by sending the parallel request, right? So it ultimately improves the performance of the web application. And we can also take advantage of multiple core processors by sending the request from different web workers, okay, parallelly. We can take advantage of web workers basically. So if you don't know about the web workers, I have created a separate video for it. I have attached the link on the I button. You can check it out. The last advantage is the memory efficient. So with this approach, we can probably develop a more memory efficient system. And how is it so? Let's understand. So when we download the entire file, we are using more memory. So in our case, the file size was 158 MBs. So when we download the entire file, we are consuming 158 MBs. But if we download the file in chunks, we can download the first chunk of 20 MB, display it to user. Then in sync, we can download the second chunk, which is of 20 MB. And after user finishes viewing the chunk 1, we can immediately show the chunk 2 to user, and then we can discard the chunk 1. So using this approach, we are only consuming 40 MBs. One is the already downloaded chunk, and then we are downloading the second chunk in the background. So this approach is pretty much used by all the streaming services like Netflix and YouTube. So what they does, they never download the entire file at once. They download the one chunk, display it to user. In parallel, in background, they download the another chunk. Once the user finish with the chunk 1, they show the another chunk to user and discard the first chunk. So this way we can utilize the memory very efficiently. And with this approach, we have very less memory footprints. Okay. So guys, I hope now you have a very solid understanding of how to download or fetch a file in chunks. Alright guys, this is all from my side for this video. If you learned something valuable from this video, then please hit the like button in order to make YouTube algorithm happy. Please subscribe to this channel and don't forget to click the bell icon so my friend you never miss any upcoming videos. Thanks for watching. See you in the next one.